Hey everyone, welcome back to JavaScript Fundamentals 201. This is lesson 5, and today we're going to talk a little bit about object-oriented programming in JavaScript. Now, JavaScript is an object-oriented language, and it might seem a little weird that we haven't really discussed object-oriented programming in JavaScript. In the first JavaScript Fundamentals course, there were some lessons involving objects and how we were one of the ways that we can create objects and use them in our code, but we haven't really talked much about object-oriented programming, and that might seem weird, but that's kind of by design, because the whole focus of the JavaScript Fundamentals series is for you to get an understanding of the language itself, because if we throw in a bunch of object-oriented programming stuff, then that kind of muddies the water, and if you're watching this course, then chances are you're either new to the JavaScript language or you're new to programming. So I'm slowly introducing object-oriented concepts so that whenever we finally do look at object-oriented programming in JavaScript, which we will do in another course, then there will at least be some information or at least some foundation for you to get started from. So with saying that, I'm going to introduce you to the first code that we are going to look at today. This creates a person object using the literal syntax. Now, the literal syntax was covered in the first JavaScript Fundamentals course. So if you're not familiar with the syntax, I highly recommend for you to either pause or stop this lesson and go through those lessons in the original JavaScript Fundamentals course. But this creates a person object and has a first name and last name property. Their values are set to John and Doe respectively. Then there is a method called getFullName, and it simply returns the first name and the last name concatenated together. So if we were to alert getFullName, we would get John space Doe. Now, if you'll remember from a couple of lessons ago, whenever we talked about functions and the arguments and this variables that are given to functions, the this variable, or you can call it this value or this object. I'm going to call it this variable. This refers to whatever object the function is attached to. In this case, the getFullName function is actually a method attached to the person object. So whenever we use this.firstName, it's actually going to get person.firstName. And whenever we use this.lastName, it's going to get person.lastName. Okay, so let's say that we want to create another person object, or at least another object that represents a person, because we might be writing some user management software, or at least some software that deals with user accounts. So we have to work with people in some way within our code. So one of the obvious ways to create another object for a person is to simply copy and paste. Naturally, we would need to change the name of our variable, so person and then person2, and then this second person would have some different information. Let's call this person Jane Doe. So now we have two objects with the same properties and method names. That's what we call the interface. So we have two objects with the same interface, and we got these two objects by hard coding them. Now we copied and pasted one, but physically within our code, we used object literal notation to create both of these person objects. And that's not really that bad of a thing, but let's also consider that we might have to work with multiple person objects within our code. If we create all of these objects using object literal notation, that's going to make our code a lot bigger. It's also going to make maintenance a whole lot more difficult because we have all of these person objects being created using literal syntax. So there's a better way that we can create objects, and that's by using what's called a factory function, a function that essentially returns a new object with a specified interface. So let's create a function. We'll call this createPerson. We need two parameters. The first is first name. Then we also need the last name. And these are going to be assigned to an object's first name and last name properties. So we want to return an object. So let's just simply return. And we will use object literal notation inside of our function here. So we'll have a first name property. We'll give it a value of first name. We'll create a last name property, give it a value of last name. And then we need the getFullName method. So we're basically replicating our person objects that we've written outside of the function, but we're doing so using the information provided by the parameters. So let's finish the getFullName method by returning this.firstName, concatenate a space, and then this.lastName. We'll finish the method, then we'll finish the return statement with a semicolon, and then we'll finish the function. So whenever we want to create person objects now, we don't have to use object literal notation because that's already done for us inside of create person. So we can create person equals create person dot, or we need actual values here, don't we? John Doe. And then we can create person 2, create person, Jane Doe. So you can see that there is some benefits for using this factory function. One of those is how many lines of code that we end up writing. Before, we were writing 7 lines of code for every object with this particular interface. Now we only write 1 because we are calling a function to do that. The second benefit is maintenance. If we wanted to modify the interface for these objects, we would have to do so for every object that we created. Well, now all we have to do is modify the returning object inside of create person, and then every object that we create by calling create person is going to have that new interface. So let's create another method. Let's call this greet, and it's going to greet other objects with the same interface. So we'll just call this object person, and then we will return a string that creates a string, hello, comma, space, and then it uses the object's getFullName method. So hopefully, whatever object we supply to the greet method is going to have a getFullName method. Otherwise, we are going to end up with an error. Now, we can actually get around that by checking to see if the supplied object has a getFullName member. So let's do if type of person.getFullName does not equal undefined, because if it doesn't equal undefined, then it's there. Then we want to use getFullName. Now we are assuming that getFullName is a method, and if we try to pass something other than a getFullName method, we will see what that happens. But right now, let's just return a generic string in case of the object doesn't have a getFullName member. So whenever we test this code, let's alert person.greet. We will greet person 2, and this will give us the string hello Jane Doe. There we go. And if we take out person 2 and pass in an object that doesn't have any properties or methods, then we will just see hello there. But if we have a getFullName property, and let's just set this to a value, this is a string, then we are going to see an error. Actually, we won't see the error, we'll just see that nothing happens. But if we look at our JavaScript console, we will see that we are getting an error. Property getFullName of object is not a function. So we need some way to work around this. Well, we could add more checks to our code, but one of the things that we do want to make sure is that our code is easy to read and easy to maintain. But more importantly, we want to follow convention. Yes, we can create objects with a particular interface by using a factory function, but we typically don't do that. Instead, we typically use a constructor function. If you remember from earlier in the course, whenever we created date objects, we did so by specifying the new operator followed by the date constructor function. This creates a date object. And we talked about other data types in the first JavaScript Fundamentals course. We talked about string, we talked about number, Boolean. We also created objects and arrays. This is how we create objects in JavaScript is by using the constructor function. It's not just because it's convention, but because there are some performance gains, which we'll talk about in a few minutes. So let's write our own constructor function for these types of objects. So we are essentially creating our own data type. JavaScript gives us that ability. So whenever we create a constructor function, we are actually creating our custom data type. So the first thing we need to do is come up with a name for our data type. These objects are supposed to represent individual people, so it makes sense if we call this data type person. So we will just create a function called person. It will have a capital letter because this is how we determine what is and isn't a constructor function. So if you're reading someone's code, and if they're following the conventions, if you see a function that begins with an uppercase letter, then you can be rest assured that that is a constructor function. So this is creating a person constructor function. You can also use function expression syntax if you want to. Either way, you create the same thing. We need a first name parameter and a last name parameter. So far it's kind of looking like create person, but this is where it's going to change. Instead of using object literal notation and then returning that object, we just create the properties of our person object by using the this keyword. So this dot first name equals first name. This dot last name equals last name. And then we need to specify the methods get full name and greet. So I'm going to copy and paste because that's kind of a lot of typing. So we just simply do this dot get full name equals a function, and edit this just a little bit. This dot greet equals a function. And then we close out our constructor function. So let's tidy this up so it's a little bit cleaner. So in order to create a constructor function, inside the this variable points to whatever object that we are creating. So whenever we call the person constructor function with the new keyword, the this variable is going to point to the object that we are creating. So it's going to create a first name property because we are assigning a value to it. The same thing for the last name property. And then get full name and greet are created as methods, and the code is the same there. So let's get rid of our factory function. And then let's call new person and new person, and we will get the same results as we got before. So let's run this, and we're not going to see anything because if you'll remember, we are passing an object with a property of get full name as opposed to a method. So if we look at the JavaScript console, we see that we are getting that error again. So we can do a different check here because now we are getting an actual person object. It's being created from this person constructor function. So we have a different operator that we can use. We can do person instance of person. This instance of operator is going to determine if this object was actually created with this constructor function. So whenever we call the greet method, it's going to determine if this is in fact a person object. If it is, then it's going to use the get full name method. If not, then it's going to return the generic hello there. So if we run this again, we will see hello there. But if we change this object that's passed to greet, let's change it to person2, run, and then we will see hello Jane Doe. Even though this is convention, it's not without its own dangers. If you omit the new keyword, you do not create a person object. In fact, you don't create an object at all. This variable would actually refer to the window object. So you would create a first name and last name property on the window object, and you would create a get full name and a greet method on the window object. You don't get an error. The only thing you get is code that doesn't work as you would intend for it to work. So whenever you call a constructor function, always make sure that you specify the new operator. Now you can get around that by actually performing a check inside of your constructor function to see if the this variable refers to window. So if that's the case, then you would call the person constructor again. So we would do return new person, first name, last name. So we're essentially using recursion to call the constructor function using the new operator to return a new person object. So that's only if this refers to window. So now whenever you call the person function either with the new keyword or by omitting the new keyword, then it still creates a person object. So this is one way that you can protect yourself if you wanted to do that. But I personally don't do that, because if I see a function call and that function has an uppercase letter, I wonder, well, is this a constructor function or isn't it? And this is just me personally. I've been writing JavaScript code for a very long time, so this is just kind of ingrained in me. If a function begins with an uppercase letter, it should have a new in front of it. So if it doesn't, then I have to go and look at the function to make sure that this type of code is there. So this is more of a personal preference, but if you do choose to do this, make sure that you're consistent in doing it for all of your constructor functions. Now, if you'll notice, this particular constructor function does not return a value, and that's because constructor functions automatically return a value. They return the object that you are constructing. So you don't have to specify return this or anything like that. That's automatically done for you. Now with the validation that I did earlier, yes, I was returning a value, but that was because this variable was equal to the window, so I was returning a new person object. So constructor functions return values automatically. Now, when I mentioned that constructor functions are convention, I also mentioned that they are more efficient. Well, as this person constructor function is currently written, it's not more efficient. And that's because we are recreating the function objects for the getFullName and the greet methods. Because anytime you write a function in your code, you are creating a function object. And since these two function objects are defined inside of the person constructor function, we are recreating those function objects every time we call the person constructor. So whenever we call it the first time for our person variable, these two function objects are created. Whenever we call the person constructor again for our person2 variable, these two function objects are created once again. So we end up using more memory because each of these function objects have to be stored in the getFullName and the greet methods for each individual person object. And we also end up using more CPU time because these objects have to be created. So we can get around this inefficiency by using a property of a function object, because remember I said functions are objects. We've talked about using them as values, but today we're going to talk about them as being objects. There's a property called prototype, and it is quite literally the prototype for objects created with this constructor function. Every function has a prototype property, but we typically only use it for constructor functions. And anything we define on the prototype is going to be shared between all other objects created with that constructor function. So we can define the getFullName and the greet methods on the prototype, and then every person object that we create is going to use those getFullName and greet methods, but we only create them once because they are actually created outside of the prototype. So I'm going to cut this code out and I'm going to paste, and instead of saying this .getFullName equals function, we change it to person.prototype.getFullName equals function. We'll do the same thing for the greet method. So person.prototype.greet equals function. Let's tidy this up to make it a little bit easier, get rid of the white space. And so now we have a constructor function that only creates the first name and last name properties, and then the getFullName and the greet methods are defined on person.prototype. Now notice we haven't made any other changes. Inside of getFullName, we are still using this.firstName and this.lastName. Inside of greet, we are using person.getFullName. And whenever we call the greet method, we're using person.greet. So nothing has changed. If we run this code, we are going to see the exact same results as we saw before. Hello, Jane Doe. But now we have a more efficient version because the getFullName method and the greet methods are only created once, and they are shared between all other person objects because these methods are defined on the prototype. Now, I don't really want you to spend a whole lot of time thinking about this. I want you to know that the prototype object is there and that it exists. But beyond that, I don't want you to spend a whole lot of time on it just because we are getting into some more advanced JavaScript programming, especially object-oriented programming. But I wanted to show you the prototype object because every data type in JavaScript, be it a number, a string, a Boolean, a date, anything like that, every method is defined on the prototype. So if you remember whenever we talked about dates, there was a method called getDate. Well, the getDate method is defined on date.prototype. In fact, if we alert this, we won't see the actual code, but we will see that the function exists because it tells us that function getDate, and then inside you'll see native code. This means that it is built into the browser, so we can't really actually see the code. But we can see that getDate is actually defined on date.prototype. So this actually opens up some doors for us. If we wanted to use the arguments value that we talked about a few lessons ago as an array, we can actually use some of the array methods by accessing those methods through array.prototype. But we're going to look at that in another lesson because we're running just a little bit longer here than usual. And I also want to focus just on this capability inside of another lesson. So we're going to stop here for today, but we'll pick up talking about using methods defined on a prototype in the next lesson. So have a good one. I will see you next time.